overcoming that type of culture had been one of the tremendous work pressure every one of us had in those days. If you answer all those kind of things, it's not necessary that only outsiders can succeed. We can also succeed, and we can also bring change into our kind of setup. But okay, we have been fortunate enough to be guided by some of the visionaries in the early ages. One of them was, you would have you would have seen the quotes of Vikram Sarabhai, who had that, he's an entrepreneur who believed that space can change the fabric of the social fabric of India. We have to leapfrog, and we have the kind of immediately after the independence, if we have the talent pool, if is all coming up, unless that we overcome the difficulties, a leapfrog in technology, we will not be able to answer the needs of the country. So that is how he's sowed the seeds of the organization, and later on it became the Indian Space Research Organization. So it's all that we have been always been taught, saying that okay, failure can happen. I agree. Somebody will say failure is stepping. You might have heard the famous phrases saying that failure is a stepping stone for the success. I personally believe that don't accept the phrase on its face value. The steps are not uniform, and unless you understand the failure, if you keep on repeating the same thing again and again and expecting different results, it's not going to come unless you understand why it failed, how it failed, and under what condition that you made a mistake. So this is the key issue for your success is understanding the failure. So this is where it actually gave us the idea that how we, given gave birth to a lot of innovations and what we are today. And see, failures do happen because we are not saying that it's because we are trying to do something which is sitting on the ground and expecting whatever your design or your creation or your assembly of things to work in a place where you have not mastered, you have not previously visited. See, how many, like for example, only a handful of people are fortunate to go to space and see what is really happening, how they can. All other people are not actually visited, but only in the simulation conditions they experience what it is, they realize what is, they study about the space. Now, there are various aspects of the space that have been studied, and you're trying to understand what is the thing. Okay, you're trying to simulate. See, for example, if I want to simulate the near zero gravity, sitting in a gravity, how do I do it? See, this is a challenge. See, nowadays you have the then you take the help of the physics. What it says that you have the balancing. Suppose in one hand, suppose there is a gravitational force. If you force with equivalent of that, so then the body will experience near zero attraction or repulsion. So people have started even for example astronaut trainings, they're all happening in using the buoyancy. That is all done with a giant swimming pool, and you cannot put your satellites into that type of situation and make crazy. So what you try to do is that we go with what is called the balloon technology. Suppose your counterweights are put in such a way with the either the gases are filled, the inert gases are filled with the balloons, and the balloon that those acting as a counterweight. So you will create the environment where that this kind of, suppose even if your mechanism, if you are designing, and if your mechanism has to work in a zero gravity condition, what is the way, how do you test that it is going to work in a zero gravity condition? So this is the kind of learning that what the thing. How do you take the whatever it is possible to do it in the ground, you do it. This is a thing. Okay, the key, again, my point is here, if you understand that your design or your product is having a failure and it is not meeting the end goal that what it is there, sit down and understand why it failed, what was the, where did we go wrong, and everything. It's ultimately it is uh, it's your own creation. Until and unless, because you have all the variables and you have played, you have made certain assumptions, and you have given certain tolerance values, or you have made certain provisions for some of the variables, but there may be another variable which you have not thought of. So, for example, if you allow me, I will tell you, I will just show you, because Anna, I'm in the shortest possible time. I couldn't come up with any video or something, but now I would like to just simple fact. I want how we actually changed so much of the thing. Now we have launched the first satellite, communication satellite, in somewhere in 1982. Apple, you would have studied in 1975 or 78, there was a special team was organized, interministerial team. That is like you have members from meteorological department, the broadcasting ministry, and the telecom ministry, and as well as the Indian Space, DOS, that is basically Department of Space, that represented by ISRO. All this put together, what should be the future communication satellite? As you know, the Apple is only one responder, that they carry only everything. It's just mainly for just to know that whether communication can happen for, because this. So, okay, now we have contract, we have put the specific, the team worked out and draw so-called RFI and whatever is, you have made requirement. And finally, the contract was supposed to was given to a company, that is the Ford Aerospace, and those days, Space and all, that is also been bought out by somebody else. It's an US company. So they were supposed to make a satellite based on our requirements and our specifications. Okay, they were also in the transition phase. See, remember, the designs are all been coming in 1978, 80. So that is the first satellite for us. It just came in. I mean, just once in a while, you please give me a feedback. Okay, otherwise, my.
Yes, sir. You're audible, sir.
Yes, it was visible, sir. Go ahead.
Okay, so that what I just wanted to show to you is this satellite. See, earlier satellites, whatever you had seen, it was all will be. It is a spinner. That is basically a drum type of a cylinder type of situation that used to have, and that used to, because the physics says that any rotating body gives you some kind of rigidity. So that where that that is the principle that all these satellite manufacturers were following. Then we have that had got its own limitation. For example, in the amount of power that what it can generate, it had involved a lot of electromechanical interfaces which will keep pointing at the communication antenna into the wherever the desired location. Then they came up with the idea of saying that why don't you keep a non-spinning object in space always pointed towards the Earth? So when you had that type of situation, what Ford Aerospace came with the other aspect, what is called, they basically they have proposed, and which also our team also accepted, this kind of what is called three-axis stabilized satellite concept. I mean, essentially, if you are able to look into it, it is just like a box type of, it's a cuboid, which will be, am I visible?
Yes, sir. Yes, sir.
Okay. Okay. So there's a kind of cuboid which is something there. So this one is supposed to be put on. This is supposed to be put on a satellite. This thing, and we were given those days. See, it's supposed to be weighing around somewhere around 1,000 kilogram, because the launch vehicles were capable of around that time 1,000 kilogram, 1,500 kilograms only for commercial use. Okay, so this is supposed, this is the kind of a satellite. So this is the INSAT 1A. We had INSAT 1, we contracted for in 1A and 1B. It is a multi-purpose satellite. It is all technology put together. Everybody wanted to this, but it is one of the beautiful design concept. And when we trying to realize that, so we had, there is I will come to the, it failed. It launched and it got into problem. It worked for some hardly about, it was launched in April, but it didn't survive beyond September of 1982. It failed. I will come to that, the failure, what lessons it gave later. But the other aspect of the, and there's another satellite which came the follow-up is the INSAT 1B, which is also this. So one of the beautiful thing is that, okay, maybe also whatever we have tried under one we have implemented, and we thought that everything is set right in INSAT 1B. So okay, launched also similar satellite launched. Okay, and the satellite will be initially it will be all folded, and it will be kept on top of this. Okay, so you have like some got the antenna folded in this side, one antenna, another antenna will be folded from here to here, it will come. And the solar, if you look at it, this is the kind of solar panel design that what we had. See, it is totally, this is the kind of structure what you will going to have, but you can't fly like this. So what it used to have is that it used to be folded, like so many folds it used to have, and finally it is it. So some of the designers used to say it is an origami satellite. So it has got so many folds. So, and mind you, the batteries what we are today, we are talking about batteries of larger capacity. Those days we had a nickel cadmium battery, that is a design available to us, and it has had only 12 ampere hour capacity. That means you cannot support all the payload all the time. You have to manage. So, but then it has to go from Earth to low Earth orbit to the sea. So initially, what happened? This configuration, once it is launched or something, this is the where that this is the point where that booster rocket is attached, and where it will take care of the satellite. So power is needed. So initially when you launch it, you will be on battery, but you can't be long. You have within about an half an hour to 45 minutes or so, you have to come on to the solar panel power for the thing. So what to do is that we have, though I had that 5-panel configuration, is one from here, one small panel from here will be deployed. That means this will generate power for whatever the requirements, and then it will move on to this one until it's the geosynchronous height. So we had all this. So fine. Then once all that, then we have confirmed that we are orbit or something, now it is ready to go for the final deployment. So then final deployment sequence is like this. So I can have to do this, and then there is one more panel come here from bottom, and this has to go down, and finally it has to come down. But then what had happened was,
Just, just, yes,
okay, so this vision it came, this things are normal. When it came to this condition, it didn't go for the, it didn't work out. So we thought that everything is taken care. There's nothing wrong in that. Everything was there, is all there. See, we have tried to issue the command to deploy once, twice. Nothing is happening, and there is no power on the satellite. And panels are stuck like this. Sun is here. I mean, sun is actually, it's grazing it like this. Sun is coming from this side. Nothing is there. And we have to survive. How we have to survive? So then nothing is, because this, you can't do anything, because all the, there is nothing in the satellite which will be able. So then how to understand what is going on, what is wrong with it? We didn't have that so-called the simulations. Okay, then we put the first thing is, what you do is, in kind of a spacecraft anomaly, whatever it is, first to put the spacecraft in the safe condition. In the safe condition, without power, nothing inside, there are so many heaters and things like that, it will not be working. So whatever the power that these antennas, these solar panels can see, tilt the satellite to that condition and leave it like that. And we managed this 1 week. We managed it because this is the way that it is, why we like. And in the meanwhile, we're trying to understand what went wrong. See, everything we checked the alignment records, we checked all those kind of things, and why it is not why it is not working. As you know that, see, all these mechanisms are coming with certain hinges. Those hinges, and when we realized after a lot of deliberations and almost like a 1 week kind of a brainstorming thing, these hinges are assembled at room temperature. That means at room temperature is number one, and number two is they are assembled in gravity condition. Okay, when there is for all this, temperature related issues, you will have the extra margin in the springs and this thing, and also you will have the margin in terms of the gravitational force and things like that. But why it is not coming? So one idea came is that just because it is aligned in, all these mechanisms are tested in the lab, which is in the room temperature, why don't we recreate the room temperature? To creating the room temperature at this space, how do we do that? That is, I told it outside is minus 269, it is all exposed, and if I can't do much about it if I want, because the hinges are in unaccessible corners. So then we came up with an idea: why don't you barbecue the satellite? See, literally we barbecued, like most of the people who go for the party, they put their eatables in the stick and then put it in the fire. So what we did is we designed an operation which will says that it will rotate thinking that yourself as the sun, I exposed it back for sometimes and then make it happen, go all the way to this side. This side is some more hinges are there. So we did it for every day. We tried 4 5 because it consumes fuel also. How do we handle? And it is moving in the orbit. So we did all these things, and finally after that all the things, it just opened up. So it gave us a lesson saying that the where you assemble and how you assemble is one of the criteria. So later on, whatever we did the mechanism, we always try the way that you assemble, that is as much as possible we create. See, and every maneuver, everything is just been created in such a way that it is, you test the hinges as an assembly, you test it to the extreme temperature. But when you put it in the spacecraft and assemble this kind of a structure, this structure has to be, once again, whenever you want the operation, you have to create back almost near to that one, then only you attempt it. After that, we didn't have any failure. I would say that until very recently, one other funny things happened. We went for a different type of antenna configuration. One of the satellites that has been attempted, you might have studied about the thing. It's like a unfallable moment. Okay, normally these structures are all fixed. It's about a few 2 meter or 1.5 meters at the So we wanted to have some other, we wanted, as Mr. Senthil would appreciate, Dr. Senthil would appreciate, because we are looking for the better link margin. So we went for a larger size array, depending on the particular to that particular frequency. I'm proud to say that Coimbatore, the Chitra, the Mr. Abhimanyu would appreciate. There is a Chitra, that is a textile association.
Yeah, South India Textile Research Association. Yes.
Okay, so they all contributed because we made with that fiber, we made actually like a stitching. We made an umbrella type of things of that, and then we made so many members, and I think we could create as if that we are unfurling that umbrella. We did all those kind of things, but at the last moment, it didn't fully deploy. It had almost like 80 to 90% it deployed, but it didn't deploy to the full. Then we realized it didn't avoid a thing. And then after so many this thing, we realized in this that certain of the elements have got a negative temperature coefficient. So when we're trying to, we use the motor to pull it out, but the temperature used to pull it back. So it is a battle of gain and loss. Whatever we try to pull using the electrical force from the ground,
No.
and then when you leave it, what is happening is that temperature gradient
Hmm.
will pull back once again so that it doesn't go to the final equilibrium condition. Okay, then how do we overcome that? So then we designed a maneuver exactly when when there is no sunlight. When there's no sunlight, we did that and we were successful. So all these things, why I'm saying all these things, it may be simple things which will be there in that. And then what was the thing is that you have to observe why and where we went wrong and how we are able to, whether we are having a handle on that. And see, you might have asked, today you have a lot of video camera is put in so many of those launch vehicles and anything, and you could have seen that. See, these are all technologies which are coming the first time, and we will be fighting for either the power and the mass. We can't optimize all those kind of things and then see that it is the thing. So unless you sit and do this kind of an evaluation, you won't be able to see. One thing we learned in this kind of thing is that don't get afraid of the failures. Don't feel ashamed about the failures. Failures do happen. But what is more important is that understand the failure, where we have gone wrong, whether we have a handle on the failure, whether we will be able to overcome that type of failure. That is one of the lessons what we have learned. And be it as a launch vehicle, be it as a satellite, be it as any other ground systems or anything which is associated. This one is we all learned. Okay, everybody makes mistake because there is nothing however careful you are, because you can't, there's so many variables, you will all be this thing. One of the this one is that I would say that the ground segment, and like for example, normally when satellites or then when we are handling the communication satellite, a geosynchronous satellite or something, that see it doesn't make that much movement for the antenna, so that it just almost like a stable thing is that. But when it goes to leo kind of satellite, the satellite moves very fast. Okay, you have to track properly. But in the purchase, one of the things in the purchase order, somebody or in the purchase specifications, whenever somebody wanted to do, hey, they just copied the specifications from one center and given to the other center. Okay, when the same unit, why don't we now? We have that famous principle. Whenever you will get, when you buy in bulk, you get some discount. Okay, so why don't you buy that? When some unit is somebody is buying, why don't you add two more and then get it? So in that way, what happens? It doesn't match whatever the requirements are in there. So before anything is there, first and foremost is that your requirements, whether your specifications are properly spelled out, whether you understand what you are trying to do, and then you try to move on. That is one lesson that what I will just do. And coming, I was just mentioning to you on the earlier this one is that there was a first satellite INSAT 1A. It just worked for hardly 6 months, and of course, it was not. It was in that so-called warranty period. It is not operated by. We were all there, but we were all supposed to be in the background. Only the contractor is supposed to. There is a foreign agency. They were supposed to be the person who is supposed to be doing the commanding on the spacecraft. So one fine morning, one afternoon, it just gave some problem, and we lost somewhere around 2 o'clock in the afternoon. We lost contact with the satellite, and they were those foreigners were trying all sorts of things, who claimed to be, like for example, they were all experts in their own field, and they were trying all sorts of things, but nothing happened. 4 5 hours, nothing had happened, and they were almost given up. And at that time, see, we were all in the background See, we didn't have too much say in that those days, because if okay, we were all brown people those days, you can say. See, only those foreigners are all no, they are knowledgeable. We are not knowledgeable. So that we can say we are brown-skinned people those days. So then finally the mission manager gave up, and then he, well, okay, if you want to do anything, you do. The first thing what we did was we lost contact with the satellite. First, anybody who loses contact with the satellite, first thing is you have to once again switch on the transmitter which sends you the signal. We just send the command. Once again, we just send a command. Telemetry, whatever what we say, the contact was established quickly. Then we realize whatever the data that comes from this one is, the satellite is almost dead. No fuel, nothing. It has happened. So then next day we have to declare that the satellite is unusable. So it is lost. So if you analyze and see that there were so many things have happened in parallel. And see, for example, they were supposed to have the switch. We are supposed, the original configuration is that we are supposed to share the one common transponder, both for telemetry, that is information from the satellite, and as well as the payload information. That switch did not work properly. Number one, it could have, if you send a command again, it would have worked. So that didn't work. And whenever there is a, see, when the spacecraft is losing its orientation, there was a safety mechanism which is supposed to uh, inhibit any kind of uh, thruster firing. So we were using bipropellant, that is two propellant, that is both your fuel and oxidizer. So that safety mechanism gave activate signal, but one wall closed, other wall did not close. So what happened? Thinking, but the control system went on driving the satellite, and finally it went out of fuel. So it like this, and these kind of things, when you sit and do that, and they were also quite surprised. And each of the team members, they didn't have the proper communication between them. What the control system fellow has done, certain things he has not documented properly. What this kind of thing. Another thing is that operationally, the people thought that just because that they are experienced, this is the way satellite has to behave. Nobody thought that there will be a simple failures like this, that uneven kind of a failures that can happen like that. So the first lesson that what we learned is document whatever is the thing. So that is why in the space regime, things are costly or things are time consuming, because documentation is more essential. Each and everything is supposed to be documented properly, that we pay a lot of attention to the documentation. After this failure, before 1B came, the boss told, okay, they were not very good in documentation. You people, whatever you know it, you better document it. So that is how we learned that each and everything is getting documented, and then the thing. So, but coming to the documentation part of it, I would tell you one more experience. In the same series, in Sat-1 series, we went to the fourth satellite. That is the INSAT 1D. It's all packed and it's all like this. Once again, it's almost same configuration. We came to this condition, and we were supposed to, we'll put it onto the top. We were trying to transport it to the launch vehicle. It's all ready. It's all fueled up. And see, there in the configuration is that there will be one fuel tank, which will be just sitting on this side. Everything was assembled, and this one, in that condition, when we normally in assembly and lifting of these structures, you will be using cranes. The crane hook exactly fell on this satellite, like this. And there is a antenna, which is a fiber structure. The antenna got crushed. It was lucky that it didn't go so deep into fuel tank, otherwise it would have been explosion. Then why I am connecting it to the documentation was that till such time, everybody thought that once the satellite is fueled up, there won't be any, you have all this locking mechanisms, I think, so that fuel doesn't leak out or something like that. There was no procedure existing at that time how to drain out the propellant, because we have to take out the satellite back for repair. There was no documentation. Then what we insisted was that some 2-3 days in that condition, then what people have worked day and night, we made the documentation. How do we drain out the propellant which is sitting there in these two tanks before we touch the spacecraft? Because it's very, very corrosive. I think we were using bipropellant because it's it's a hypergolic. When you say hypergolic, you don't need a spark plug to make them ignite. Anywhere it comes into contact, and these two comes into contact, explosion takes place. So we have to handle safety, and we have to safely drain out the propellant. We did that. So we based on this experience down the line, and somewhere in when I was in Antrix, I was handling one of the international contracts, the same condition. The satellite is fueled up and sitting in French Guiana and Kourou. I asked, things have changed. It is not foreigners. It's more like our own ISRO colleagues who are specialists in the propulsion related area. I asked this thing, where is your, I thought that I had the authority to ask because being the paymaster, I asked, where is the unloading procedure? He jumped on me and said, who are you to ask that type of questions? Because there was we had bitter arguments on saying that such situations will not come. You don't need a documentation. You don't need. So then I said that no, because up to beyond certain level, because I cannot. I'm not the. Though we raise all the concerns and something that okay, it's the top management which clears the for further operations. I agree. So luckily that mission went through. But down the line, you might have seen that there were certain missions which were recalled back at the last moment, which needed these draining procedures. Whatever that you have propellant that is loaded, you need the DLC. So one thing is there. Let us not what we learned and what we are trying to get. It's not that all the time that things will work in the way that you like. You have to be prepared for something untoward. Think about it, and then put down the even the like. For example, there is a famous saying: the palest ink is better than the most retentive memory. You may be having everything in the memory, but doesn't work. At the time of crisis, if you need a sheet of paper to look into that and then do this kind of thing, so that you need a documentation. Second one is like repeating that word like James Bond movie, never say never again. Some people will say never say, okay, I don't need this. But we always would say that never say never again. It will not happen means there is a likely chance that it will happen. When it happens, are you ready to handle? That is the situation that is, that's much more. It's applicable to all fields of life. See, for example, whatever has happened in this pandemic period, who thought that, you need oxygen supply this much? Okay, you had this kind of because some down the line that you need certain of this infrastructure kept in the beginning. So this is another thing that what you were saying that I just wanted to say the importance of the documentation, importance of the understanding of the failure. And the third aspect that what I would like to stress upon is that don't give up. If you give up, you are not going to meet the requirements. We had situations, I'm speaking from the satellite point of view, the critical components in the satellites have failed. I had a situation, payload, everything is perfectly working. Sorry, how much time I have? I didn't see the time properly.
you can go ahead, sir. Go ahead, sir.
Yeah.
Prompt me if I am too long. Okay. So, okay, we had a situation where the satellite is beautifully working. Unfortunately, the backup battery is not there. It works only during sunlight. So, when there is no sun, when batteries are failed on board, we have a situation how to handle. How do we put this satellite into use? So then we came up with the. Okay, no, it's all. I would say that I worked more on this particular area. We just again took the principle of physics. In the physics, you have the one of the concepts. This thing is a spinning body will be more stable. I mean, you have studied about the inertia numbers, the moment of inertia, and things like that. If you have a box type of structure like this, and let us say that if your moment or the moment of inertia is maximum along this particular axis, a rotation about this axis is going to be more stable than the rotation about this particular axis. So unfortunately, when the satellite it is when studied about all these inertia's numbers, and we have this one, we put it in such a way that when there is no sunlight, we return to the old concept like the spinner. We put the satellite in a spinning condition. It will be stable with respect to the attitude wise, but it won't be usable because the way that it is. Okay, fine, no problem. So we have geo satellites. We have experienced 45 days of eclipse in two phases. Like the one will be centered around September, other one will be centered around March 21st. So this 45 days your satellite is not available, no problem. But at the end of the 45 days, it will come back. So we design maneuvers, it will come up and we will recover, and we used to do that. So though nothing, this is one satellite we managed. The other, this experience gave us one more thing. Another critical satellite which lost its critical sensors used for attitude management. How do we manage? So whatever the data that sensors used to give, we used to feed it from the ground as if we fooled the control system, saying that you are looking at this wherever you are supposed to. So that whatever the target information, whatever the processing required for the control system, onboard control system, we used to feed it from the ground. So essentially, we kept the man in the loop. The man is supposed to be sitting in the ground. And man in here, later on, he replaced by the machine, because initially we were doing and we were doing manually, but afterwards we put some algorithm and see, look at some pattern parameters, and we generate certain sequences, and then we used to give it. This way, we handle that satellite till its last. The failure happened in the initial years, maybe first, second year or third year it happened. Probably second year it happened. But we kept the satellite alive for next 13 years. So this is one of the this thing. Why I'm saying is, if any other people would have given up, but don't give up. That is one other issue, that what is the one essential thing that what we have done. Then this is the third aspect. Then you will have this, many people over, you all would have traveled in aircrafts and things like that. See, aerospace industry uses always redundancy, because we are all looking for redundancy. Okay, hardware wise, you will be having the redundancy and thing. What happens if there is supposed to be certain calculations which are supposed to be done for the critical operations? How do we do that? So then we came up with this one, is that there will be two teams, totally independent approach. Okay, if suppose somebody is following certain algorithm, the other team will follow totally different algorithms, and the results have to converge. And unless there is a match between these two, the operation will not be planned. This is a way that the thing. So we have taken it to such a level, saying that it used to be joke before we issue data. I mean, let us say, for example, something the spacecraft has to be given certain data, like say 22.3245, and higher management used to comment that first decimal will be given by X, second decimal will be given by Y, third decimal will be given by Z, like that. It used to be to when you want to improve upon the precision mechanism, independent thinking is the one that actually gives you the you don't only to say that there are many routes to achieve the same thing. Some may be shorter, some may be longer, but the question is, are we reaching the destination? That is the one, that is what is needed. So you may have, for example, you may your final results maybe now why to spend, why one team is sufficient, it is not possible to think. But whatever be your limitation, have an independent cross check. If computer is doing certain things, simple thing is manually calculate and check whether it is all fine. That is another way of doing it. You don't need a two teams. Okay, there is somebody has written a program and somebody is giving you the results, the computer gives it. Don't believe the computer. So this is what had happened. Sometimes what happens, somebody has fed the wrong information into the computer, so you got a results and believed the computer, timing is there, so you uplink to those command. Satellite looked at different direction, then they realized that it is somebody has given a wrong input. So never to, there are some people who questions each and everything, because the questioning mechanism, if you build it properly, that is another aspects of this one, is the one that is shaped. These are some of the issues that and I would just, I thought that I will uh, uh, share with you before now this thing. And I mean, I have been going on like this for quite some time now, and I'm open for discussion. It is better that if you, when I, let me just have a pause at this moment, let me invite your observations or your questions from here. Maybe I will be able to respond better. Thank you.
Thank you, sir, for taking us all on a space ride. Right, it is like 2 points which you have to take home. One is it appears that you are the space doctors, though you call yourself engineers. It appears that you have been a space doctors maintaining the health and the life of the satellites. That itself is a massive, massive task. And another thing, what take home today is this: failures on its own will not lead to, may not be a stepping stone for success, unless and otherwise you understand the reasons for the failures. So with these two major points, I think since the time is extended, I think my people can put their questions on to this thing. We will compile the questions and forward to you. That may be a better thing, so that they will have a proper replies, sir.
No, any quick questions, I'll be able to respond, sir.
Okay.
No?
Any team members, you can go in with the short questions. Any questions? Open to the meeting.
Yes, sir. Hi, sir. Vishesh here, sir. I'm the Constellation Design Engineer, and it was a wonderful webinar, sir. Like wonderful set. Sir, I'm just wondering. Okay, like back in those days, in 70s, 80s, like we didn't have those technology as what we have right now. Like those very precise, accurate technologies, right? That's just a bit technical, but I was wondering how did the satellites then perform those very precise station keeping requirements? Because most of the satellites at those times were probably sent at the GSOs or the SSOs, the sun synchronous orbits, right? And the sun synchronous orbit falls around 600, 800 kilometers, where you have a lot of atmospheric drag and everything. And to maintain the lifetime of the satellite, and then you have the moon, a pull of the moon, and then the J2s and all those things. So how exactly like did they perform such accurate station keeping requirements?
Yes, no, I would say that we did that, we do that. Okay, as you said that today, like you may have all the latest tools, but algorithms have not changed much. It's the same algorithm. Okay, see, you might have added some more terms to that. You may get an accuracy number. Like see when you have the pi 3, whatever the number it is 22/7. and you can expand whatever you want. And those days, the computers, what we had is, let's say, 8-bit computers or 16-bit computers. I agree. But today you have 64-bit machine. Your accuracy numbers is something is better. See, okay, what happened used to be that in order to arrive at accuracy, to answer your questions, the observations have to be made more often. So that will tell you that refine that what your number, that what you need to do it. See, it is again the same technology what our ancestors have done that. They were also predicting all that, you have that so-called panchangs. See, they say that today we claim they are more accurate that when that grahan is going to happen and all those things they have done it. They didn't have any but algorithm. They only believed in the algorithms and the thing. Once you are having a correct algorithm in your hand, it might have taken some 1 hour calculation. I agree, but that 1 hour would have whatever the results that you are trying to do is that is what is more than this. Okay, the same thing. I'm not trying to boost myself. I am. I did my thesis in image processing. I did it in PhD College of Technology, Coimbatore. We didn't have computers. We didn't have, hardly speaking, there is a TDC 16 computer. That means 16-bit TDC, ECAL computers. They used to run only COBOL. COBOL is a commercial software, the accounting software. That only they will write. We have to do the punch card business. That only they do it. So we have to request the computer center people to load the Fortran compiler and to run the scientific program. So we did it and also, and I joined. I somehow finished my thesis and got the degree, and then came to the same program. I ran in my master control facility using the computer. What used to take for me about 3 weeks time, nearly about 1 hour computer time. 3 weeks time means because the error correction and all the because those will not load. What used to be the running time of 1 hour in my college days, it used to be giving me results in 10 minutes. I'm talking about 1982, where our computers were having memory of 192K. It is not even MB. We are all Ferrite core memory business. So algorithm is, as long as it is fine, you will be able to get the results whatever. That is how the people have moved. Even for example, the moon and beyond. Those days, whatever it is nothing but the calculation. I don't know whether anytime you have used the slide rule. See, people have forgotten slide rule. We have forgotten clocks tables, right? Because it's already calculated and I mean, my brother's son who recently completed mechanical engineering, and I asked him, "Have you bought the design data book?" Because in 1 hour times, the whatever the machine design people used to carry one design data book. There's a big
Yeah, red color book from PhD.
some kilogram book. That's it. I said, I don't need it. And then how many classes of drafting classes you attended? No, that is all. Now only CAD classes. There is no drafting class. He doesn't know. He has not purchased a mini drafter at all. So it's a like this only. So there is evolution is that it is going on, but we have to accept and proceed. Accuracy numbers, I agree with you. You will get to the thing. Then you have to account for it. This is how the uncertainty goes. I will just do this. Thank you.
Thank you, sir. Thank you.
Any other questions? Any other questions? I request the team people. If you have any other questions as a later thought, please compile it and forward it to the organizer. Wishes you can collect the questions and the doubts, whatever the participants have, and you can forward it to sir, and we can answer them individually. Right?
Sure, sir.
And thank you. One final message.
Sir,
I just want to give you. See, whomsoever it is, like for example, I just only wanted what I have. Never be ashamed of your failures. See, when you are working in a team, okay, we are bound to have certain differences. This thing, well, your results will turn out to be different. But if you allow your everybody to express properly and learn from that, you will be making a very good team rather than putting down somebody. So never feel ashamed. Open discussions, open mind is the one that what it is. That is the culture which we grew up, and I believe that future generation will carry forward. Thank you so much.
Thank you very much, sir. Rajesh ji,
Yeah. Thank you, sir. We'll proceed to the vote of thanks, formal. Wishes, there is one question from Prithvi Raj. You can note it down and maybe you can reply him on his personal. Prithvi, you kindly share your email address so that we can get back to you on the question. Okay, in the chat box. The question is in chat box, right, sir? So, thank you very much, sir, for a wonderful session. It was really very much interesting because for us, we only read in the newspaper the mission is successful or mission is failure, but the kind of efforts entire team like you is taking behind each and every small aspects is really commendable, sir. We thank you very much, and we can relate it somewhat with the Genu because we are also into developing customized robotic solutions, and for us also it goes just like a trial and error. We keep on trying, we keep on alteration, we keep on improving each and every stage by taking the feedbacks. So this session of yours giving the importation of documentation and other minute details of how a project can be taken forward will be definitely useful for our entire team. We once again thank you very much for joining this session and look forward for your continued support in future as well. We conclude
Thank you
here.
so much. It's been pleasure, mine also, and thank you for the opportunity to interact. Though I couldn't see all of them because my screen is size is limited.
Yeah.
Someday I would hope to meet all of you in person. Until such time, thank you so much. Dhanyawad.
Thank you, sir.
thank you.
Thank you, everyone. Thanks for participating.
Thank you, sir. Thank you very much, sir.
Thank you, sir.
Thank you.